Welcome to day 3. Today, we're diving deep into the very heart of artificial intelligence, control flow. Think of AI systems as incredibly smart assistants, constantly making thousands of tiny decisions every second. How do they achieve this seemingly intelligent behavior? It all comes down to how they manage their internal logic and data. As you see, AI systems fundamentally rely on control flow for their decision-making processes. Every AI system, from a simple spam filter to a sophisticated recommendation engine, is built upon two core concepts. First, conditional logic, like if-else statements, which enable the AI to make precise choices based on specific criteria. Second, loops, which allow it to efficiently process massive amounts of information, iterating through information repeatedly. Without these fundamental building blocks, AI would be incredibly limited, much like a calculator that can only add. These concepts are absolutely essential for intelligent AI behavior, allowing systems to classify information, make accurate predictions, and understand complex inputs in dynamic environments. Today, you'll learn how to build these decision-making brains yourself, setting the stage for truly intelligent applications. Let's start with conditional logic, the AI's primary tool for making decisions. At its core, this involves using if-else statements to evaluate specific conditions. Imagine an AI system needing to determine if incoming data is suitable for training its models. It might ask a series of questions. Is this data point missing values? Or is it the correct data type, like a number or a string? As highlighted, if-else statements are crucial for tasks like data validation, ensuring that only high-quality information feeds into the AI model, preventing errors and improving accuracy. The simple Python function, validate training data, you see here mimics what happens millions of times in real AI training environments. It meticulously checks for missing data, insufficient length, or invalid data types, returning false and a specific error message if any of these conditions are met. Otherwise, the data is considered perfectly valid for use. This fundamental ability to evaluate and respond to different conditions forms the very basis of how AI systems classify information, filter out noise, and make intelligent, reliable decisions. While conditional logic helps AI make individual decisions, loops are what enable it to handle massive amounts of information and learn effectively over time. For loops are incredibly powerful for processing large datasets efficiently. Think about the need to clean and prepare thousands or even millions of data points before feeding them to an AI model. A for loop iterates through each item, systematically applying validation or pre-processing steps, such as normalizing text data by converting it to lowercase or removing extra spaces, ensuring consistency. Then there are while loops, which are absolutely essential for controlling AI model training iterations. Models learn through repetition, continuously refining their understanding and improving their performance. A while loop simulates this by running training epochs or cycles until a target accuracy is reached or a maximum number of iterations is met, preventing infinite loops. These repetitive actions, driven by both for and while loops, are absolutely crucial for continuous learning and improvement. They allow AI models to refine their predictions, adapt to new data, and become more accurate and robust over time, forming the backbone of any learning algorithm. Now, real-world AI systems rarely rely on just one isolated type of control flow. They combine them in sophisticated ways. This powerful technique is known as nested control flow, where loops contain conditionals, or conditionals contain other loops, creating truly complex and powerful logic to tackle challenging problems. A prime example is an AI content moderator for social media. It might first use a for loop to go through every single post. Inside that loop, an if statement checks the post's initial validity. Further within, another for loop could scan the text for specific banned words. And finally, a series of nested if-else statements would decide whether to remove, review, or approve the content based on a calculated risk score. To make this tangible, consider our feedback AI example. This practical system efficiently processes a batch of customer feedback. It uses a for loop to iterate through each piece of feedback, an if statement for initial validation, and then calls a function that itself uses nested loops and conditionals to analyze the sentiment of the text. This sophisticated combination of control flow allows the AI to validate incoming data, process information intelligently, and classify it with high accuracy and nuance, demonstrating how these fundamental building blocks form the backbone of practical, intelligent AI applications. The control flow patterns we've explored today aren't just theoretical concepts for learning. They are the invisible engine powering every major AI system you interact with daily. Think about Netflix recommendations. Behind the scenes, complex nested loops tirelessly process your vast viewing history, while intricate if-else logic meticulously decides which movies and shows perfectly match your unique preferences. Or consider email spam detection, which employs continuous while loops for learning and adapting to new threats, alongside detailed if-else statements to classify each incoming email as spam or legitimate with remarkable precision. Even highly advanced systems like autonomous vehicles rely on incredibly complex conditional logic to make split-second driving decisions. If an obstacle is detected, then immediately brake. If the road is clear, then accelerate smoothly. These seemingly simple patterns, when combined and scaled, enable AI systems to handle millions of decisions per second in production environments, forming the invisible intelligence behind modern technology. Mastering control flow is truly thinking like an AI engineer, understanding how decisions are made at scale. As you look ahead, remember that these powerful decision-making processes need data to operate effectively. Tomorrow in Day 4, we'll delve into data structures like lists and tuples, the essential containers that hold the massive datasets your control flow logic processes, preparing you for real machine learning scenarios.